This video is going to be on the aromatic compounds for the Unit 4 specification, and I'm going to start with understanding benzene. So there are two types of organic compounds, aliphatic compounds and aromatic compounds. Aliphatic compounds are what we're used to by now, and these are just straight or branched chained compounds. Aromatic, on the other hand, well, these are just compounds which contain a benzene. So what is a benzene? Benzene has the molecular formula C6H6. Its structure is all of the carbons and the hydrogen atoms form a planar ring, and planar just means flat. The delocalization, well, each of the planar carbon atoms has a pi electron above and below. These electrons therefore merge, because you can think of it as the electron density, all merges, and this is above and below the carbon plane, the 2 pi electrons, forming two rings of delocalized electrons. And then the stability of benzene is due to its delocalized rings, so to reiterate, it's the delocalized rings which cause benzene to be stable. That's a lot to take in, so I've kind of done a diagram here. It's not the best, but it's the only way I could draw it. So on the right here you can see that we've got the delocalized ring above, the delocalized ring below, and in the middle we've got our plane of carbon atoms with their retrospective hydrogen atoms. So you should see that these kind of make 3 layers, and the way that I like to remember it is think of a burger. We've got the plane in the middle here, which is the carbon plane with the hydrogens. Below we've got the lower delocalized ring, and above we've got the upper delocalized ring. That'll be a way you can remember that it's planar, because you may be asked questions about its structure in the exam. Okay, so moving on from burgers. Before the actual structure of benzene was identified, we need to know about Kekulé's model, and that this was the closest model to what we know today as being benzene. So his proposed structure was he based his structure around the cyclohexene. He proposed that benzene was made up of alternating single and double bonds. So we know that cyclohexene is basically this, with obviously a double bond. So what he decided, Kekulé, is that benzene was going to be something like this. Alternating single and double bonds, single, double, single, double. However, it turned out that his proposal was wrong, and that's because analysis of benzene shown that the bond lengths were all the same, and if they were alternated, double bonds are shorter than single bonds, so they wouldn't be the same. And just a bit of extra knowledge, the actual bond length was in between that of a single and double bond. Okay, so further proof that Kekulé's proposal was wrong was because of the enthalpies of hydrogenation. Cyclohexene, we know, has an enthalpy of hydrogenation of minus 120 kilojoules per mole, and that you can see here. Kekulé's concept then, we'd think if it's got 3 double bonds because it's alternating, you'd expect it to be 3 times that of cyclohexene, sorry. So it'd be up here with a value of minus 360. And that is what I've wrote here. However, in reality, the enthalpy of hydrogenation of benzene is minus 208 kilojoules per mole. So on my diagram here, that's here, and that's further proof that the alternating single and double bonds cannot be true. So that's all you really need to know about understanding benzene. It might not make sense now, but once you take a few exam questions using this information, it'll all fall into place.